So let's look at some distributions and what they do. We use a binomial distribution when the outcome is binary, like succeed, fail, get heads, tails, get a specific card or not, get a specific side from tossing a die. The main framework here is either you get it or you don't. This is how you know you can use a binomial distribution. Let's go through an example. You throw a coin 6 times and you want to get tails 4 times. A coin has a 50% probability for each side. Just a note on representation. In most discrete distributions, you will see this representation part of the calculations for the distribution functions. Let's just go through this right now. You say n choose x, which is the same thing as saying n factorial over x factorial times n minus x factorial. This is also seen as n big C x. All this means the same thing. The calculations will have more elements, but this is the main part of it. I just want you to be clear on the specific element. So let's continue on. N equals 5 trials. You want x equals to 4 number of successes. The probability of succeeding is 50%, and the contrary to that is 100% minus 50%, which is in this case 50% as well. So the probability for this situation after the calculation, it's 23.44%. There is a special case of the binomial distribution called Bernoulli distribution, where n equals 1. Everything is the same, the only difference is that n equals 1. This means that in our example, you only throw the coin once and the experiment is over. So you throw a coin, the probability of x is equal to heads, and it's 50%, and the experiment is over.